Hopefully by now you have a little bit of an idea of how hashes work and how valuable they can be. Let's take a look at some of the features of hash. We can access the keys in a hash as an array by calling .keys. We can also access the values in the same way by calling .values. As of Ruby 2.0, hashes adopt a natural ordering. That is to say, when you add a new key value pair to a hash, the order stays in the order that you inserted it. We might want to sort a hash in some other way, however. To do this, there are multiple approaches. In the first approach, we can simply sort the keys of the hash. Let's imagine we have a hash which associates numbers to characters. So 3 to C, 1 to A, and 2 to B. We sort the keys of the hash by calling hash.keys.sort. Of course, as you remember, this is sorting the keys in lexicographic order, which is numerical order when we're talking about numbers only. Let's say we want to print out these values in order. We can call each to iterate our sorted keys array, pass an argument called key to the block, then using puts include key in our string using interpolation, and then we have to do a lookup for the value that that key associates to. But printing these items out might not be all that valuable. It might not be what we want to do. Imagine we want to create a new hash which is the sorted version of the previous hash. To do this, we would create a new empty hash using the two curly braces and assign it to a variable called sorted hash. As we iterate our sorted keys, we're going to add the values back into sorted hash. Now remember that hashes adopt a natural ordering. So as we add the values in, they're going to retain that order, which of course is now sorted. There is an alternative method to sort our hash. It hurts my head sometimes using this method because there are so many block arguments, but feel free to use this one if you prefer. Recall our sort method on an array. We had to pass two arguments to a block. First was the first comparable object and the second was the second comparable object. Then we have to define how those two objects can be compared. It's the same in a hash, but this time we have to pass both the key and the value for each argument. We can put these inside normal round brackets to separate them. And then we can use our comparison operator. In this case, I'm comparing the keys, but I can also compare my values, or I could compare some combination of these. The trick is that when we use this method, we don't actually get a hash back. What we do get is an array of two-element arrays. So we have to take advantage of a special way to create a hash. If we pass an array of two-element arrays to the special method hash, note this has a capital, then we actually get a hash back. The two-element arrays are converted into the key value pairs used in our hash. Looking at our sorting example, we can use the array of two-element arrays and the hash method to create a new hash which is sorted. This approach to sorting a hash may seem a little complicated and convoluted, but it's actually quite a lot faster than the previous method, so I encourage you to give it a go. No prizes for guessing the exercise in this lesson. I'd like you to create a method that takes a hash as an argument and returns a sorted version of that hash. Good luck with the exercise, and we'll go through the solution in the next video.